Hi, this is Avinash Pandey, and here I'm going to present you my assignment for big data technologies. So after cleaning the raw data manual in Notepad, I could import it on Studio 3D for having MongoDB connection and execute it on Python. The ID that I have used for Python is Jupyter Notebook. And here in this part, you can see I have imported all the important libraries, Python libraries such as Pandas, sklearn, PyMongo, NLTK, and TextBlog, etc. That will be required further in the execution part later. So Pandas is a must-need library in the data science lifecycle since it is heavily used for data analysis and cleaning process. Likewise, there is extensive use of NumPy and other libraries such as Matplotlib that helps for graphs and plots for data visualization process. So moving on to the first question of the assessment, we do have this part one extraction, and inside extraction, we need to address schema based feature. So this category is related to properties of a social item. So after fetching the data from MongoDB, we can see here we put it in data frame and that shows ID along the text. ID that represents the username and text. You can see the tweets here that has been done by the user. So this part and the first question, the first part has been addressed for schema-based feature. So moving on to the next part for lexical-based feature, you can see we provide a token for each of the items. So we allocated them into tokens, and we removed the URL from all of the text. So after putting it into tokenized words, it has the sentences has been segregated into every single word separated by comma that you can see here. Similarly, after using all the process that has been done using analytical library and all of the words has been assigned with a separate keyword that you can see here. Similarly, here in this part, you can see for a name, Suzy Walker, that has been assigned a keyword such as person for only $40. It has been assigned money, so you can see the lexical-based feature has been addressed here in this part. So moving on to the next part for time-based feature, again, we created a data frame df1, um, and you can see here push time that generates the time of the tweets posted. And here you can see actor, it has different attributes such as ID link, display name, posted time, and all those. Similarly, moving on to the next part, location-based feature. This category is related to the mentions of locations in the schema of the item. So we have taken Melbourne City for the Twitter time zone, and we took 5 tweets that you can see here that has been posted from Melbourne. So this part also has been addressed. So moving on to the next part, data enrichment. Here in this part, after using analytical library, we could go further with data enrichment. Here in this part, I have used knowledge source WordNet, which is a vast lexical database that contains English words, nouns, adjectives, adverbs that are organized into scene sets, which expresses a separate conceptual, semantic, and linguistic linkages. Like hyponymy and autonomy are used to connect sets. Likewise, here in this part, eagle, here you can see it's indicated as noun that you can see here. And similarly, lion, when we are using lion as a state lion.n.01. So it defines large gregarious predatory feline of Africa. So here in this part, the definition of hypernym states that if X is hypernym of Y, then all Y are X. Likewise, it also states that let's say here a lion, sorry, if animal is hypernym of lion, then all lions are regarded as animals. So um, that you can see here. And moving on to the next part, synonyms and antonyms. Using this function, we could get synonyms for respect, keyword as esteem, honor, regard, respectfulness, and antonyms as disrespect, esteem, etc. So moving on to the next part, NL-based semantics. Here you can see we use the function coordinate lambdizer, and we clean tweets, we filter tweets, and we could fetch the data as tweets. And that you can see here, similarly, we could take the help of count vectorizer, and here we have used a function called count vectorizer that delivers a sparse matrix defining all words for fetching keywords. We do tokenization process that breaks down the sentences into words. Following to that, we perform the vectorization process by the usage of count vectorizer. Here, the words that are being tokenized are changed into integer matrix that follows a conversion using TF IDF function that you can see here. TF transformer function vectorizer. So TF IDF, commonly known as term frequency and inverse logarithm function, that you can see here. So moving on to the next part here, tweets will be here you can see with the usage of sort matrix and sorted matrix and extracted top keywords function. These two functions will help us to extract the TF-IDF score and being sorted in descending order along with top keywords using the function extracted as listed below. So we put all of these in data frame here that you can see. For this text, we got the keyword as work. So using all of these, the part NL-based semantics has been addressed as well. So moving on to the next part, data analytics and visualization. First of all, we need to do the sentiment analysis. So sentiment analysis is the automated process of identifying emotions in text. And here in this part, we are using the Python package text log for calculating the ID values of each individual tweet. Will initiate by creation of text log objects that allocates ID values to each tweet. Also, we can make an identification of ID value with the usage of ID text log objects. So first of all, we are creating a data frame from tweetel, and that has column ID and text. So we can see with the predefined polarity subjectivity, and using this function we could get the values for subjectivity, sentiment, negative, positive, neutral, compound. So we can see here sentiment denotes the overall sentiment of the tweet, and so we need to put it into values. So here we have got the results that you can see 905 Total number of tweets, neutral tweets, and percentage is 39% for similarly 13% for positive and 20% for negative. And putting it in a pie chart that you can see here, and the percentage denoted as well. So again, doing the sentiment analysis from text log here, we took the values from polarity along with the text aligned to it. So we plotted a histogram of polarity values here, and since it's not clear visually, so we need to remove polarity values equal to 0 or less than negligible. So removing all the values equal or near to 0, we could get a more clear histogram here. So that addresses the sentiment analysis and visualization process. So moving on to the next part, which is the last part of the assignment as well, that's clustering, similarity computation and visualization process that you can see here. We fetched the Wikipedia data for cricket, football, hockey, and soccer, and we fetched 150 sentences from Wikipedia and put them into data like this. So for doing this process, we need to import Wikipedia library. Okay, and moving on to the next part, we need to take help of the function word space tokenizer as well. Similarly, word net lematizer, and we need to clean the text that has been fetched from Wikipedia. So here, this function cleans the text. So similarly, we need to define two more functions that are similarity function and get score function that you can see here. So here in this part, we have page Twitter data. Here you can see tweet will be passed along with the group, whether that can be whether that can be from either of the groups. So similarly, we could get the score, and data has been put into data frame here in this part, so that you can see here as a result, and plotting the data frame in histogram that you can see soccer has high frequency, whereas cricket has the lowest. And moving on to the next part, the elbow method of clustering executes the k-means algorithm on data for a specific range of values wanted, let's say, following to compute an average score for either value of k in all clusters. So for doing this, we need to import k-means from sklearn library. So this is the album method for clustering, the album method. So we need to do this k-means function as well. So here in the last part, we need to define a function that visualizes the clusters that is done here, and we plotted it in scatter plot as well that you can see. And this addresses the clustering, similarity computation, and visualization. That's the last part of the assignment. So we have addressed all of the three parts of the assignment, and it's completed. And here comes the end of my explanation for assignment 2 for big data technologies.